Okay, so in this session, we are going to understand how exactly data engineer works and what are the roles and responsibilities in this role, and how a person can become a data engineer, even with like if you have a zero experience in any data role, then also how you can become a data engineer. So this webinar is all about these kind of people. Now, how many of you are already working as a data engineer? Is there anyone who is already working as a data engineer here? Okay, so no response from anyone. So is there nobody who is working as a data engineer in this session? Can all of you tell me like what is the current profile in which you are working? It can be any profile support. If you are a fresher, if you are an experienced person, just write your things in the chat so that I can understand what kind of audience I'm dealing with today. Okay. Okay. So first of all, let's try to understand how data engineer people work and what is the main thing that you need to understand in data engineering. So the first thing that you need to understand is like what is big data? If you are a kind of person who want to get exposure into data engineering and if you don't know what is big data, then there is something that you need to be serious of. So if you don't know what is big data and directly you are learning PySpark and all other technologies, then it is something that you don't need. Like you first of all you need to understand what is big data. So I am Durgesh and currently like I'm working as a senior data engineer at 7-Eleven, and previously I used to work at Target as a data analyst, and along with this I have experience of teaching in multiple institutes like Boscoder, Masai School, Newton School and Geeks for Geeks. And by gathering all this experience I have around 4 years of experience in teaching, and multiple of my students are already placed in very good companies, and 90% of them were from different background. So they were not from computer science or any background, they're from BA, BSc, MSc, these kind of backgrounds. Now why I say that understanding big data is important, because if you want to become a data engineer, the first thing that you need to understand is infrastructure. So right now I don't know how many of you have this idea, but you need to understand how the data is stored. This is the first thing that you need to do. Know how the data is stored, how the data is processed. These two things are most important for a data engineer. How data is stored and how data is processed. Along with this, you need to have a knowledge in three kind of different data. So there are three kind of data, you can say sources, or you can say there are three kind of data which is getting generated. So one is structured data. My voice is low. Am I audible to all of you? Okay. So one is structured data. Second is unstructured data. And the final is semi-structured data. Now, again, you need to know about all these three different kind of data. So currently, if you are a data analyst or if you are an engineer or if you are a software engineer, you mostly have dealing with this structured data that comes in the form of rows and columns. And for learning this data or for working with this structured data, you normally use SQL as a programming language. Now, if you talk about big data, if you talk about big data, so big data comes in all these three formats. So big data comes in all these three formats. Why this comes in all these three formats? Because if you talk about Amazon as a company, then you know that in Amazon there are multiple kind of data. Like if I talk about structured data, so if you see orders table, let's say if you talk about orders table in Amazon or any kind of tabular information in Amazon, so that will be considered as structured data. Now, at the point of time when you once you do a payment, so let's say you are on Amazon and you have selected one product and now you want to pay for that product. Now, once you do a payment for that product, you are doing it from the third party vendor, or you can say you are doing it from the third party, and that third party can be your credit card or that can be your UPI. Now, at the point of time when you are doing this payment from Amazon application with the help of your credit card and UPI, now at that point of time you have to interact. So your Amazon application needs to interact with your UPI or credit card platform. And to interact between UPI and to interact in this way, or if you want your UPI or credit card to interact with the Amazon app for your payment, then you must be sending some responses from your app to these websites or to these particular credit card or UPI application. So at this point of time, when you are sharing information between two applications, then you need API. So API is basically application programming interface. So now let's take an example. If I have to book a ride on Uber, now Uber is having their own map also, but that map is not something that Uber has made. That particular map is created by Google Maps. Now, if Uber wants to use Google Map as the application in their platform, then they need to send responses to the Google Map application and Google Map, or you can say they will ask a message to the Google Maps application and Google Maps application will send a response to them, because of which you are able to do live tracking on Uber, that where is your ride currently, all those things. So all this API data comes in semi-structured format or in JSON format. So now if I give you an example how JSON format looks like, so you can take an example, let's say ride partner, and ride partner let's say is Abhishek, comma, ride amount, and let's say it is 550. So if you see here, this values, if you see this is the key and this is the value associated with the key. So API responses or JSON responses come in key value format. So these are kind of structured only, but these are not in the form of tabular structure. So that's why they are known as semi-structured. Now the third thing. So now when you try to put a review on Amazon app. So many of the times you have seen that in Amazon app you see videos also of a product, or you try to send a photo as a review. So all this kind of data is known as what? This is all unstructured data. So mostly the data which comes in audio, video or multimedia, this is unstructured. This has no structure. So Amazon as a company or any big data company uses all these three kind of data. And why they use all these three kinds of data? To make their application better. First is this thing, and second use case is to enable more orders on their applications. Now, this is the reason why they deal with all these three kind of data. Now, if you have an understanding of these things, then you are a kind of person who can like, okay, like if you have understanding of these things, then you can go for like, okay, I want to become a data engineer and I have basic understanding, so I can start learning the tools and technologies. This is something now. After this, the next thing that you have to understand is, okay, we have all these three kind of data, but how this data will be stored? So you cannot store this data on a single machine because this data is very large. Every day, around 3 millions of people order on Amazon. So you cannot store this data on a single machine. Even if your machine has, let's say, 1 TB of RAM, then also you cannot store this data into a single machine. Now to store this data, we need machines, or you can say we need multiple machines, and all those multiple machines are connected in parallel. When I say are connected in parallel, I mean to say that in a single machine, each and everything is not stored. So data is distributed into multiple machines. Now, if somebody wants to request the data, then if the data will be stored at multiple machines, then multiple machines can work together to give you the final output. So that will be fast. But if all the data is stored in a single machine and it is large amount of data, then if multiple people will request data from a single machine only, then it will be slow. And let's say if your machine go failed, then you will lose all the data. So because of that, your data is your machines are connected in parallel, and all machines have different data and some copies of data also. So when I say that if I want to request some data, I can go to multiple machines. But if I can go to multiple machines, it means that my data needs to be stored at multiple machines. So let's take an example. If a company is there who is using machine one only, who has only single machine, and this machine is very good, like it has around 1 petabyte of storage, 1 petabyte of storage, and let's say 30 to 16 core CPU. When I say 16 core CPU, I mean to say that 16 tasks you can perform at a same point of time, and let's say it has 64 GB of RAM, or let's say 128 GB of RAM. So this is a specification of a machine. So simply try to think now, when I say that data is getting stored, data we have to fetch, data we have to analyze, we need a storage, we need a processing, that okay, you have stored the data. Now if I will write the queries, I want a result also. So I need a RAM as well for processing that result. And if I say why CPU is required, so multiple people can work on a single machine and multiple tasks can be performed. So we need a CPU also. Now, if I have data in only machine one, then what will happen? Right now, let's say 10 people are there who want to use machine one, and the data requirement of the company is also very less. So now this, for this particular case, this machine is performing in a better case. Now, if you talk companies like Amazon, then Amazon is getting lot amount of data, and if they will store all data into a single machine, then there are millions of users who are tracking, who are checking their order details, who are ordering something, who are seeing their products. So now this single machine cannot solve all this problem, so they have thousands of machines connected with each other. When I say connected with each other, so the simple thing that I wanted to say is, let's say if I have a data, let's say if I have a 1 GB of data. So what happens is this whole 1 GB of data is not stored in a single machine. It gets distributed into multiple machines. So let's say if we are distributing this data into 4 machines, let's take an example, then each machine will get 256 GB of data or 256 MB of data. Now you will be saying that, okay, let's say this machine has got 256 MB of data. Now, still also, let's say if 10 people wants to access this 256 MB of data only, then they all have to interact with machine 1, yes or no? They all need to interact with the machine 1 only, because this multi machine has particular 256 MB of data. So now this is not solving the problem. Okay, I am dividing the data, it's very good. But the point is, still machine 1 has a particular data, and if somebody wants to access that, then they have to interact with the same machine only. So that is a problem. So now what happens is that this 256 MB of data is stored on this machine, but copies of this data will be stored on multiple other machines also. And this is known as replication of data. So data is replicated, and you can decide your replication factor. Let's say if a replication factor is 3, then your data or particular data will be replicated to 3 different computers or 3 different nodes. In data engineering terms, these are known as nodes. So these computers are known as nodes. So now if this copy of data is in 3 different machines, so let's say if 100 people wants to request it, then some people's request will go to machine 1, some people will go to machine 2 which have the same replica of data, and some people will go to machine 3. So that's how the workload is distributed. And if workload is distributed, then everything will be fast. And the best thing is that let's say if this machine got failed, this machine got an issue and this got completely failed, still we have the replicated data on 2 different machines, so we are not losing the data. So that's how data engineering, or you can say big data architecture, is defined, so that data is fast to process and we are not losing the data. So now all this infrastructure, so when I say all these things, machine 1, machine 2, you must be thinking how these machines look like and how these things looks like. So I will show you an example of it. So this is how these machines are kept together. So let me give you an example. This one. Are you able to see the example? So like this, you have the whole infrastructure set up, and there are like lakhs of machines connected with each other. And this is known as data center. Now, data center is a place where all the machines are connected and are powered with local area network. Why local area network? Because if they will use normal internet, then normal internet does not have that much speed. And the second reason why they use or they connect everything with local area network, because they want security as well. So that is the reason companies create their own data centers. But this data center creation and all these things are part of 10-year-old infrastructure. So these things like companies setting up data infrastructure, this is something that is happening 10 years back. Now we have cloud computing. Now we have cloud computing. Now, what is cloud computing? So, every company that works with data analytics or data engineering or data science, they all use or they all work with cloud computing. Now, think it like a scenario. You are a company and you are a small company currently. Okay, you have set up your own data center with little bit infrastructure. But right now, if your company is growing, then you have to make your data center very big. You have to plan a very big infrastructure, and you have to handle multiple responsibilities. You will hire multiple people, and you will do all that hassle, and it will cost you a lot. It will cost you a lot. So today's company don't create their own data center. Today companies want that all this data center and everything, all the physical infrastructure and all these things, they don't want this hassle. So what they do is they hire cloud providers like AWS, Azure, or GCP. They hire these cloud providers. Now, what these cloud providers do is these cloud providers give them the complete functionality that they can get from their physical data infrastructure on internet. So with the help of these three cloud providers, you get all the facilities of storing, processing, and working with your data on internet only. Now you must be thinking that if they are providing all these services over the internet, then what about security? So these all AW, Azure, GCP, all these provide you a high level of security, and that they do with the help of IAM, which is Identity Access Management. Now, one more thing, that if a company, let's say, has its own in whole infrastructure set up on AWS, now for setting it on AWS, they need a first of all they need a storage, so they get a data warehouse. But this data warehouse is a kind of a structured storage. When I say structured storage, then I mean to say that all the data which is at raw level, after cleaning, after making it formatted in a better way, this is stored in the form of a schema inside my data warehouse. So simply you must have heard about ETL, extract, transform, load. So let's say there is a source, and source is, let's say, a kind of a application. Now from that application, this data will be loaded. Then based on the requirements, this will be transformed. So when I say transformed, so let's say the data type of a data is in different in the raw data. I want to make it in a different data type in the like transform data, or I want to remove some columns, or if I want to remove the duplicate rows, all those things I will do in the transformation. And once I have transformed this data, I will load it into data warehouse. So now data warehouse is a place where you can do all your SQL queries and everything in terms of. So now for this, AWS has Redshift. For this, AWS has Redshift. Azure has Databricks. Hadoop has Hive. And we have Snowflake data warehouse. We also have Google BigQuery. So now the point is that whenever you go as a engineer or a data analyst, also even if you go as a data engineer or a data analyst into a particular company, you need to know these tools, because there you are not using SQL server and all. So these cloud providers provide you all the things. So that is, this is something that you need to know if you want to go for a data engineering profile. These all things you need to know. And these are on the fundamental side. These are very basic fundamentals needed to know. Okay, this is one part of this session. Now, the part two of the session is how data engineer works. So when we talk about how data engineer works, so the main task of a data engineer is to understand two things and to connect them. Like Ashutosh, why you are like feeling this thing? Is there something that I'm not telling you or something like that? So the point is, Ashutosh, like so there are multiple people who are at a very basic level who don't know multiple things. So that's why I'm trying to explain them with the easiest way possible. So if you like, if you feel that it is not interactive, then you can ask like questions. Yeah, I can understand. I got your point that you want it to be more interactive, by which I can ask questions to people and I can answer them based on your questions. I got your point. Okay, so till now, if anybody has any questions, you people can ask and I can help you with that. Till now, is everything clear to all of you? What we have discussed? Please respond in the chat if till now everything is clear to all of you. Okay, great. So now the second thing that we need to understand is that the real task of a data engineer is to connect two sources. So the first source is upstream and the second thing is downstream. And a data engineer is a person who connects upstream with downstream. So data engineer is a person who connects upstream with downstream. Now this looks very simple that a data engineer has to just connect upstream to downstream. So now upstream is what? Upstream is basically source of data. Upstream is source of data and downstream is basically final useful, or you can say finally used prototype, or not prototype, finally used version of data. I will give you an example, then you will be able to understand. So let's say there is a source of data, which is a kind of a CSV file. Let's say the source of data is CSV file. Now this CSV file has, let's say, 1 million records. Now this is in the form of CSV file. This is in the form of CSV file, and this CSV file has 1 million records. Now, the first thing a data engineer has to do is, so this is the upstream source. Upstream source is CSV file. Now, this file has 1 million records. Now, the first thing the data engineer has to do is it has to load this. It has to load this into a storage. So the first thing that a data engineer do is they try to store this file into a raw storage. So now if I say a raw storage, then I will take an example of Amazon S3. So Amazon S3 bucket is an object based storage in which we try to store our raw data. Now let me tell you what is this object based storage. So a object based storage is a storage in which every file or every document or everything that we are going to store is independent. When I say independent, so let's take an example. In your computer, you have a downloads folder, and inside downloads folder, there are multiple like files there. Now your files are dependent on download folder. So if you copy your file, then it will be dependent on your downloads folder because they are saved inside download folder. Now if somebody deletes the download folder, your files will also go. So here your files are dependent on a folder, and that folder can be dependent on any other folder. So that is dependent way. Now when I say independent or object based storage, so it is same like Google Drive. So if you see each and every Google Drive file that is there, you can copy the link of it and you can share it independently. Yes or no? Same like this, in Amazon S3, data is stored. So the data that you will see inside Amazon S3, it will look like that it follows a folder. So if I show you, let me give you an example. Yeah, S3 is the object storage, or you can call it as a blob storage. Let me tell you. So this is your console. Now this is AWS. Now if I open S3, so S3 is the storage of Amazon. So now if I show you here, there are multiple kind of buckets. So in S3, we store data inside buckets. So if I want to store data, then I can store it in the bucket which is already there, or I can create a bucket and I can store data in that. So let's say this is a particular bucket that I have created, data load transfer. So if I click here, if you see there is a file here. Now, right now you must be thinking that this is a kind of folder structure in which in the data load transfer bucket we have a CSV file. So this structure looks like a kind of what? A kind of folder based structure, but actually this is not. So all the files that you see here all are independent. So you simply have to copy the S3 URI and you can use these files. So it is same like Google Drive. Is this clear to all of you till here? Okay. So now you loaded your, so and mostly the raw data is stored in Amazon S3. Now, once this raw data is loaded, once this raw data is stored in S3, so for making this CSV file load into S3 bucket, you need a kind of load. So this part, or you can say this particular process in which you are exporting CSV file into your Amazon S3 bucket is known as extraction phase. So this is extraction. You are extracting the data. Now, once you have extracted the data into your S3 bucket, now you want to create a structure of it, or you want to store this data in a good structure. Let's say currently all CSV files have the data type as string. All the columns, whether it is amount or anything, everything is in string format. Now, to make your data perfect, you need to do what? You need to make the data types perfect. You need to make columns perfect so that your data becomes meaningful. So now the second thing that you will be doing is you will be loading this data, or you will load this data into a data warehouse. Now it is not necessary every time to load the data into data warehouse only if you want to use it into data warehouse. So here in Amazon we have Redshift as a database. So now it is not necessary every time that we have to load the data into Redshift, only then we can query on it. No, there is something known as Redshift Spectrum also. So now if you want to directly use this data as a form of table from S3 directly without loading it into a data warehouse, then also you can do that. But at an ideal scenario, what you people do is you try to load this data into a data warehouse. Now understand data warehouse as a kind of a storage which is big data storage. So normally you use database, here you have data warehouse. Now in data warehouse, the first thing that we have to do to load this raw data is to create a schema. So schema is basically the structure. So if I want to load this CSV file, which is right now in Amazon S3 bucket, and if I want to load it in my data warehouse for querying it, then first of all, I have to create a schema of this file. I have to create a table structure of this file, columns, data types, and everything. Once I will be able to create the schema of this file, then simply I will load it, or simply I will load it into data warehouse. Now once I have loaded it into data warehouse, now my data is in the form of structured table. Now data is loaded. Now the next thing that we are going to do is, so next thing that we are going to do is we are going to transform this data. Now what I mean by transforming this data, so let's say based on my requirement, based on my downstream requirement, let's say I want to see a kind of dashboard from the CSV file. So my downstream requirement is to create a dashboard. And to create a dashboard, first of all, I have loaded the data in the S3 bucket so that it is stored there as a raw data. Then I have tried to load it into a data warehouse so that I can perform my tabular operations and SQL there. Then the third thing that I will be doing is I will be transforming this data. So I will be transforming this data based on my requirement. So let's say if I want to see a dashboard in which I have to show month on month sales or day on day sales. So based on that requirement, I will be transforming this data by writing my queries over it, or by cleaning it, or by doing other things on it. So now this thing you do with the help of PySpark, or you can use SQL also to transform this data. Once your transformation is done, in this transformation stage, so in this transformation stage, when I say your transformation is done, so there are multiple kind of things. So some people follow medallion architecture. Some people follow medallion architecture. So what is medallion architecture? Medallion architecture says that we will have three layers: bronze, silver, and gold. Now, why people create this medallion architecture? Because they want to make their data perfect. So, what is bronze? So, bronze is the layer in which we store raw data, and as it is from the source. In the bronze layer, we store data as it is from the source. We don't do any modifications in it. In the silver layer, we try to transform the data. We try to transform the data, and we try to create better fact and dimension tables. So based on the data, we create fact and dimension tables. All joins and everything we perform here in the silver layer. And once we are done with the silver layer, we create a data set or a table of the final data. That is silver level data. And in the gold layer, we try to do final transformations which are based on business requirement. Let's say I got a data which is Amazon sales data. Now in the gold layer, I will try to do those things. Let's say I want to see day on day sales, then I will write a query and I will make a data set of that particular result so that I can power it in the Power BI to show day on day sales. So business transformations are done in gold layer. Now this is one way of medallion architecture. Now after this everything is done, our data is transformed, and in the gold layer we have final tables or final data sets which have the final transformations applied. Then I will connect this to Power BI. And when I will connect this to Power BI, in Power BI I will see the dashboard. Now if you are creating a dashboard, then you need it to update every day. So for all this process that we have done, we have to create a automated way that everything, this whole process works by itself. And that is known as pipeline or job. That data engineers do mostly on the daily basis. Now, if you are a very better data engineer, then along with the medallion architecture, you will also create one thing which is known as data quality checks. So one person have asked a question in the starting in this session, how to ensure data quality. So for this data quality only, that we are very sure about the quality of the data, we have DQ checks. So these data quality checks are kind of checks that we apply on our transformed files. And these checks are mostly null checks, null checks, primary key check, duplicate check. So these are normal level checks that we apply on data quality as a data quality. But if you are a person, let's say your stakeholder has said that for this particular, let's say your stakeholder has said that this particular data is there, and if you see any invoice amount as negative, or if you see any date which is a futuristic date, I don't want that column, or I don't want that row. Or if your stakeholder has said that wherever the tax for a product is greater than 9.99, I don't want that product, that is a junk record. So all those kind of checks you can apply here, and those checks are known as custom checks. Those checks are known as custom checks. that you apply on a custom level based on the stakeholder requirement. But normal level checks are these null, primary key, duplicate, and negative amount, positive amount, these kind of checks. Now, these custom checks are kind of checks that we have to create by ourselves. Above things we also have to create by ourselves, but these checks also we create by ourselves. And for these kind of checks, we mostly write a SQL query. Let's say if I want to check that whether my data is duplicate or not. So I know my granularity. I know that my data, if it is duplicate on these particular three columns, then this is a duplicate. So I will write a query based on my three columns that no data can be duplicate on these three columns granularity. So those will be something that I will write. A better data engineer is a data engineer who can provide checks on all these three layers. So let's say if I have checks on all these three layers, or let's say these two layers only. So then for this layer, I will get to understand what source is creating a problem. And in this layer, we will get to know if we have created something problem. So we will be very sure with the data. And in this data quality checks, we try to create automated emails as well. So when I say automated emails, let's say a particular check got failed. Let's say a particular check got failed. And now we want to understand what was that check and because of which how many rows are failing. So that you can get automated on your email. That 1,000 rows failed, failed in in day duplicate check of DQ framework. Now, all the people who are connected to that mail, they or the stakeholders who are connected to that mail, they will simply get an understanding that there is something issue with the data. And the most popular check that we keep in the bronze layer is file uploaded or not. So let's say source has not provided the file on the correct time. Now because of that you are not able to load that data. So you also want a notification na, that file got uploaded or not. So all these kind of notifications and these things you can provide in the DQ checks in the bronze layer. So now these are the things which data engineers do in real life. Now here multiple things, other things are also there. Let's say if your pipeline fails, then what you have to do. Let's say if your Spark is not working properly, or if your data is not optimized, or if your queries are not optimized, then at that point of time, we as a data engineer do multiple kind of things in between. I will show you one example of a pipeline so that you can understand what exactly it is. So let me use Databricks here. So I have to log in once again. Just give me a minute. So if you see, this is Databricks, and then this Databricks, I have created a Snowflake data pipeline. So this data pipeline is doing what? It is fetching data from Snowflake data warehouse and it is making it into Databricks. Then it is applying all the checks on it, bronze, silver, and gold. And then if you see here, this is the pipeline. So this pipeline has multiple these things. So first we are trying to set up the connection between data warehouse and Databricks. Then we are ingesting the details. Then in the silver notebook we are trying to do the things. Then we are applied data quality checks also. And finally we have created final gold tables. So if I show you, let's say this file. So let me show you this file. So all these files are automated. They will do steps one by one. I don't have to run them manually. So if you see in the first file, we have tried to set up the connection between Snowflake and Databricks. Now in the second file, which is ingest orders, let me show you. So here what I'm trying to do is, here I'm trying to load my data from data warehouse, which is Snowflake. So see, first of all, I have run the setup, then I am loading the data. So, and when I'm loading the data, I'm saving it as a bronze table. See, bronze products. After that, when I have loaded the data, I am in the silver notebook. I am trying to make that data more perfect. So this is how the silver layer is there. So we are trying to check whether a column is null or not. All these checks we apply here in all these tables. And once everything is fixed, we will try to make them as a silver table. So silver table is a kind of data set where you have your fact and dimensions ready. And finally, this is the data quality. So I also want to create a data quality check whether my data is perfect or not. So if you see here, we have applied data quality checks. Like if our order ID is null or not, if a total amount is less than zero, then we will create a kind of thing that this is not a perfect data. And finally, once everything is checked, we will create our final data set, which is a gold tables. So these gold tables are perfect and they have actually the real data that is needed. And here you do all your aggregations. So if you see, I want to see based on a order date, I want to see total revenue, total orders, and total customers. So in the gold layer, I have created my final data set that I want to show in the UI. And this data set I will use in Power BI. So I cannot explain you everything in a single class, but one thing I can say that all these things are required. So teaching in Boss Coder from last 1 year and in multiple institutes, I have got one thing that the best way to learn data engineering is to are you using so basically I mostly use PySpark, but I have 100% knowledge in Pandas, PySpark, and SQL, everything. Like so I have worked with multiple things and I have taught them to multiple students. So if you ask me anything like Snowflake, Hive, मैंने सब कर लिया है तो I can teach you anything. But in this class, I hope you are clear with what exactly data engineering looks like. Is everybody clear? Just respond in the chat box if you people are clear. See, I'm not saying that you will be clear 100% with all the things, but I hope that you people are clear that what exactly it looks like. Now, the thing is that currently our cohort is running. So that cohort is a cohort that got started. So in that cohort, basically we are so in that cohort is basically engineering analytics cohort, in which from a zero level we are making people to understand everything that they need to get into a product based company. So I basically teach to people to get them inside product based company only because in service based companies you cannot learn a lot of things as compared to a product based company. So this is my curriculum and this cohort is again going to start. The new cohort is going to start in the month of April. So if you see, first of all, we try to make a person analytics ready. So this cohort is for all the people who want to become a data analyst or a data engineer. So if you are doing this cohort and you want to become a 2 years data engineer, then you are perfect. And if you want to mold your 3 to 4 years of experience of data analytics, then also this cohort is perfect. This is all for freshers and for experienced people and for experienced people in the same domain as well. So if you see here in the first 3 weeks, this cohort has all live classes, and along with the live classes, we will be helping you with multiple things like your resume, your LinkedIn, and also to help you with assignments and the real things that you need to do. So if you see, first thing we have here the analytics foundation. So currently we have completed till Python, SQL. So like you can say 4 weeks are done. So our analytics foundation is first thing. Second thing, if you see, is big data architecture. Now, even if you are a data analyst, you need big data architecture. So this curriculum that I have created for you, I can 100% say you will never find this curriculum anywhere in the market because people try to teach you everything. And in this particular cohort, I am teaching you those things that can make you ready for a product based company, even if you are at a zero level. So the second thing is big data architecture. Third thing is week 7 to 9. So see, again, if you are want to become a data analyst and if you are only learning SQL, Python, Excel and Power BI, I will say that right now job is not for you, because there are multiple other things that are needed, because you are working in a big data company and you have to work with big data architecture. So you have to do these things. So here in the week 4 to 6, at least like for 3 weeks, we will be focusing on big data architecture. Then from week 7 to 9, we will be focusing on data pipelines and engineering. So this is the best phase of this session, in which you will be able to understand how real system works, and there will be nothing something like theory and all. The people who have attended my classes or who have learned from me, they know that I only deal with practical. I don't teach theory, because see, same thing if you are learning from me at any different institute like Newton School, Geeks for Geeks or Boss Coder, there you people pay a lot of money. The thing is that this particular version that I have created exactly deals with how you can become a best in the particular domain so that you can get a job. So all these things are there in this particular. So there are three capstone projects, and these three projects are very practical. These three projects are projects which you need to crack any role, and if you'll tell these projects to the people or the interviewer, then interviewer will 100% say that this is the person who has exactly worked with data. He's not fooling. And now, for what kind of people this course is? This course is for all the people who are freshers. This course is for people who want to switch into data analytics or data engineering. This course is for people who have a gap of 2 to 3 years and want to start again. And this course is for all the people who think that they cannot do coding. But I can prove them that you can do it. Like, if I show you my LinkedIn profile, so there are around, I can say there are multiple people whom I have helped to get placed as a product in a product based company. Now I'm not saying simple things. If you go and if I search any of the profiles, so these are all my students. You can go and you can talk to them. These are all my students. Here, if you see, you can take a snapshot, you can talk to them, and you will get to know how I have taught them. They were from different background, and today they are working in top companies, and they were from different background. So I know how a person can become or how a person can get into analytics. Now, so that's all for the session. If you want that particular sheet link, I can give you the sheet link also. So let me give you the sheet link in which I have explained you the things. Now, all the people who are interested and who want to join the cohort from March end or from April, then they can directly reach out to me, and I will like give your details to the team so that team can contact you. So this is the sheet link that we have covered today. And if you want to connect with me, then I'm giving you my WhatsApp contact. You can directly reach out to me, and if you reach out to me, then I will not tell you about course and all. I will connect you with a specific person who can explain you more about it, and who can tell you each and everything about price structure and all. So right now we are running this course at 30% discount and 30 to 40% discount. And this is all for, like, in this course we will be helping you exactly how you can get placed. So this is not a placement guarantee course, because nobody can promise guarantee. But the thing is, like, if you have joined this course, then until you are not placed, we will be helping you like how you can get and how you can move ahead. So this is my WhatsApp contact I have given in the chat, and it's an Indian number, so you can connect with me on WhatsApp. If you don't have laptop, then the things will not be correct. Now you need to have a laptop. You can buy a second hand or you can do anything, but you need to have a laptop. So I have given my number in the chat, all those who are interested and want to learn from me. And if you think that I can teach you the things and I can make you perfect in this particular course. So see, I am not a company. I am not a company like big company. I am just an individual and I have my courses on TopMate and I used to help people to get into this domain. And exactly I know how they can get by cracking multiple companies like Atlassian, Uber, Ola, 7-Eleven, Target, ServiceNow, Credit B, United Airlines. I know what exactly it requires. And I can tell you one thing that in the last 2 years, like all the technical interviews that I have given, I only failed in one. So I know what exactly it requires and I can teach you. So now that's all from my side. If you people are interested, then please ping me on WhatsApp. Mahesh, I will share you the drive link today. I have seen your message like few days back only, but I thought that I have replied, but I have not replied. So I have seen your message just now. And for sure, Mahesh, I will send you the drive link. Okay, so so the person who is saying I'm new here, but this is has been what I want to learn. So I have given you my contact number at the top now. You can reach out to me. And if on a so currently this course is at a 35 to 40% discount. So the initial cost of the course was 55,000. Now currently after 35 to 40% discount, you will get this course between 33 to 36. Now, if you are thinking that this course is costly, then I will again say this is not costly. The same thing I teach in multiple institutes, and there the fees is 1.5 lakhs. And you all know that in institutes, what is the fees? So I am teaching you at a much reliable cost, and you are learning from a person who has teaching plus engineering experience. So that's how I am different, and how can I help you? And what is your view about AI regarding data engineering? See, AI's view is, I will tell you, AI is something that can make your work easier, but for making your work easier, you need to know the work. And to need to know the work, you need to understand the technologies. So I will say that AI can help you a lot to be productive at data engineering, but it cannot do everything as a data engineer.